Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering a whole new topic called Authentication Vulnerabilities. In this video, we'll go over all the fundamental knowledge that is required to understand authentication vulnerabilities and complete the 14 hands-on lab exercises that we'll be covering in the upcoming videos. Alright, let's get started. The agenda for today is to first cover the technical details behind authentication vulnerabilities. So, what is an authentication vulnerability or an authentication flaw? What are the different types of authentication vulnerabilities? How common are they? And so on. Next, we'll cover how to find and exploit authentication vulnerabilities. So, if you're given an application, how would you go about testing the application to see if it's vulnerable? Then we'll end the presentation by covering the different techniques that you can use to prevent or mitigate authentication vulnerabilities. All right, let's get started with the first section, which is what is an authentication vulnerability? Now, before we discuss authentication vulnerabilities, we need to understand what authentication is. Authentication is the mechanism that is used to identify the user and confirm that they say who they say they are. So let's say, for example, you've got a user who's named Alice, and Alice needs to log into her account on this application. Now, the application needs a way to verify Alice's identity before presenting Alice with all of her information. And the way the application does that is by using form-based authentication, where it asks Alice for her username and password. And if Alice provides the correct username and password, it presents Alice with her information. So that's pretty much it. That's what authentication is, the ability to verify a user's identity. Now, the application in our example used the classic HTML form-based authentication, which most websites use today. However, there's tons of other types of authentication mechanisms like multi-factor authentication and Windows integrated authentication using NTLM or Kerberos. So this one over here, we usually see only in internal networks. So in the intranet versus internet, so that you don't have to keep logging into internal applications in your organization. Now in the presentation, we'll only focus on the first two types of authentication, HTML form-based authentication and multi-factor authentication. Alright, now that we understand the definition of authentication, we're ready to define what authentication vulnerabilities are. Authentication vulnerabilities arise from an insecure implementation of the authentication mechanisms in the application. This could be the result of a design flaw, a business logic flaw, or even a configuration flaw. So it's really difficult to enumerate all the different types of authentication vulnerabilities that are out there. So what we're going to do is we're going to instead go over the most common examples that we've seen in real-world applications. And we'll start off with the classic one, which is having a weak password requirements or weak password complexity requirement. I've seen many applications that have no or minimal controls over the quality and complexity of users' passwords. So for example, they would allow you to set very short or even blank passwords. They would allow you to set dictionary words or names, and they would even allow you to set passwords that are the same as the username of the user, which is terrible because this makes it easier for an attacker to either brute force your password or guess at your password and get unauthenticated access to the application or to your account. Another thing that I've come across is the use of default credentials when using off-the-shelf software. So in a pen test, when I identify that you're using an off-the-shelf software, the first thing that I do is go to the online documentation for that software and see if it chips with default credentials. If it does, I automatically test for those credentials, and I would say about 50% of the time, the credentials haven't been changed, and they're usually for high privileged accounts like the administrator account. So it's absolutely important that you change any default credentials when deploying off-the-shelf software. One thing that I did want to bring to your attention when discussing this topic is the Consumer Authentication Strength Maturity Model, or in short, CASM. It essentially allows you as the consumer to identify at which level you are in terms of authentication strength, and depending on that level, what you could potentially be vulnerable to. So for example, over here, the worst level or the most insecure level is number 1, which is shared passwords. The definition for that is that you use the same password in multiple places across the internet. And that's probably the majority of the users on the internet. So you could see over here, for example, your Gmail password is the same one as for Netflix, it's the same one as for Wells Fargo, and so on. And what that leaves you vulnerable to is credential stuffing. So we see a ton of breaches happen almost every day now, and then you've got millions of passwords being shared online. Now, as an attacker, if I was a malicious actor, what I would do is I would get your password for, let's say, Gmail, if Gmail was compromised, and then I would try it on Netflix, and then I would try it on a ton of other applications to see if you use the same password. And chances are you did use the same password or a variation of the password that is leaked. And this way, not only is your account for the application that was hacked compromised, but your account on a ton of other applications have been compromised as well. And so you could see over here, this is the worst case scenario. The second worst case scenario is using unique passwords, but they're too short, simple, or contain personal information. We talked a little bit about that when we discussed password complexity requirements. And then it goes all the way to passwordless, which is that you've got managed passwords. Your 2FA comes from a physical token or your mobile desktop's built-in trust center. So over here, it leaves you vulnerable to hardware compromise, which is really difficult to perform. You actually need to gain access to the user's physical devices in order to be able to compromise the user's account. I would say to be secure in today's landscape, you have to be level 5 or even I would argue level 6 and up. So you definitely need to have multi-factor authentication enabled. That's the bare minimum. We see breaches happen all the time, and like I said, millions of passwords are getting dumped every day. So you really no longer can depend on single authentication to keep you secure. Another example is improper restriction of authentication attempts. So that's when the application permits brute force or other automated attacks on authentication mechanisms like the login page, the one-time password, or the multi-factor authentication page, or even the change password page. I usually see some kind of restriction on authentication attempts when it comes to the login page, which is good, but it's usually missing when it comes to the OTP page or the MFA page or the change password page. So it's important that all the authentication mechanisms have some kind of brute force protection. Another example is using verbose error messages on authentication mechanisms. So in the login functionality, if you put in an incorrect username, the application responds with the error, sign in failed, incorrect username. But if you put in a correct username but an incorrect password, you get a different error message saying sign in failed, incorrect password. So the fact that the application responds with a different error message depending on whether the username or password is incorrect allows an attacker to enumerate the list of valid usernames in the application. Another really simple example is the use of an unencrypted channel to transmit sensitive information like user credentials or cookies. With HTTP, it's an unencrypted channel, and so anyone that is sitting on the same network as you can intercept your traffic and view it in clear text. Here, I've got an example where I logged into an intentionally vulnerable application, the OWASP Juice Shop application, and you could see over here when I tried to view my credentials on the same network, I could intercept the username and the password that I used to log into the application. Whereas when you compare it to HTTPS traffic, which is an encrypted channel, although I perform the same login, when I intercept the traffic, it all looks like gibberish to me because all the information is encrypted and I won't have access to any of the credentials that are passed in the application. And so it's absolutely important that all your communication is done over an HTTPS or an encrypted connection. Next, we have an insecure forgot password functionality. The example we've got over here on the screen is a design flaw in the forgot password functionality that allows you to change your password if you know the answer to the secret question, what street did you live on in Sierra Vista? Now, the reason this is insecure is one, there's only a finite number of streets, and so this automatically decreases the pool of potential answers to this question. And the second reason is that with a bit of OSINT, which stands for Open Source Intelligence, you could probably find that answer online on the user's social media accounts. And so it makes it much easier to compromise a user's account using the forgot password functionality versus having to compromise the user's password on the login page, which undermines the overall application's authentication logic. And that's why I always say when it comes to testing for authentication vulnerabilities, you're not only testing for the login page, you're testing for all authentication mechanisms in the application. Another example is a business logic flaw in the way the multi-stage or multi-factor authentication function is implemented. So you've got over here an application that employs MFA. It first takes in the username and the password of the user. If the username and password are correct, it prompts the user to enter the verification token. When the user enters the verification token, it sends this request to the application, so /login steps /second, and then it logs the user in. Now, the issue with this multi-factor authentication function is that one, the verification code is not tied to the user ID, and the way the application is keeping track from this request to this request, so the way it's keeping track of the session is using a cookie called account, which is equal to the user's username. Now, the issue with that is that as an attacker, what I could do is I could log into my, let's say, self-registered account. So I would put in my username and my password, and then it'll prompt me with my verification code, which I'll get on my phone. I will put in my verification code, but I'll change the cookie from my account to the account that I want to compromise. And if the cookie is not tied to the verification code, using my own verification code and my own credentials, I could compromise any user's account on the system as long as I know their username. So you definitely want to be careful when it comes to the logic of all authentication mechanisms because one mistake could potentially compromise all the users on the application. Last but not least is insecure storage of credentials in the backend database. So this is both a cryptographic failure vulnerability and an authentication vulnerability. When you're using plain text, encrypted, or weakly hashed passwords, you leave the user at potential compromise if your application ever gets compromised and the database gets leaked. So having plain text passwords is the worst case scenario because then an attacker could just use the password and compromise the user's account. The second one, which is not obvious to most people, is using encryption to store users' passwords. So as a user, you are entitled to no one knowing your password except yourself. The administrators of the application shouldn't know your password, and anyone who has access to the server shouldn't know your password. And so user passwords shouldn't be encrypted, they should be hashed. The next one is using a cryptographically insecure hashing algorithm like MD5, which is known to have collisions. And then using a cryptographically secure hashing algorithm, but then not salting the hashes, which leaves the database vulnerable to dictionary attacks. And so these are all examples of authentication vulnerabilities that you need to test for. All right, let's move on to discussing the impact of authentication vulnerabilities. So we've touched a bit on that in the previous slides, but as usual, when I discuss impact, I like to measure it in terms of how it impacts the SIA triad. So confidentiality, integrity, and availability. Now, for authentication vulnerabilities, they allow you to compromise a user's account. So, by definition, confidentiality, integrity, and availability are all affected because if you can compromise a user's account, then you have access to view, update, and delete their data. In fact, once you find an authentication bypass vulnerability, the next goal is to chain it with another vulnerability in the application to give you remote code execution on the underlying server. All right, the next question is how common are authentication vulnerabilities? One way to measure that, and it's not bulletproof, is the OWASP Top 10 list. For those of you that have not heard of the OWASP Top 10 project, it's essentially the list of top 10 most critical security risks facing web applications today. It's updated every couple of years, so you could see over here we've got the 2013 list and then the 2017 list and the most up-to-date list as of this recording, which is the 2021 list. For authentication vulnerabilities, Historically, they've been the second most critical security risk facing web applications, but they did fall down to the seventh most critical security risk facing web applications today in the 2021 list. Regardless, they're still one of the top 10 most critical security risks facing web applications, and so they should definitely be taken into account, considering one, they allow you to compromise user accounts, and two, after you do compromise user accounts, it gives you a much bigger or a much wider attack surface, since now you not only have access to public pages, but you have access to authenticated pages as well. And that's why in the previous slide, I said when you do get an authentication vulnerability, the next step is to chain it to another vulnerability to gain remote code execution on the underlying server. Alright, in the past couple of slides, we discussed what authentication vulnerabilities are. We saw a few examples, and then we discussed the impact of authentication vulnerabilities and how common and critical these types of vulnerabilities can be. In this section, we'll discuss how to find authentication vulnerabilities. So imagine you've been given an application and asked to test it. How would you go about testing this application to see if it's vulnerable? I've divided this section up based on the examples that we saw in the previous section. So we'll go over how to find and exploit each vulnerability that we discussed, starting with the first one, which is the application employing weak password complexity requirements. So when you're testing an application, what you could do is review the website for any description of the password complexity requirements. If there is a self-registration functionality, it should be listed there. But if it's not, what you could do is just register accounts that contain bad passwords. So for example, you could try and register a very short or a blank password. You could try and register a common dictionary word or name. And then you could also try and register a password that is the same as the username. If you identify that the application allows you to set weak passwords or is missing multi-factor authentication, then you should definitely report it as a finding in your pen test report. And this goes also for the change password functionality. So sometimes rules are being employed on the login functionality, but developers forget to employ these rules on the change password functionality. So any authentication mechanism should be tested for this type of vulnerability. Next is improper restriction of authentication attempts. So the first thing you need to do here is identify if there is any form of brute force protection that the application employs. To test for that, what I usually do is just manually submit several bad login attempts to accounts that I control. If after 10 failed login attempts I don't get locked out, then chances are there's no lockout mechanism. So in that case, the next thing to do is run a brute force attack using a tool like Hydra or Burp Intruder to enumerate the list of valid passwords for the valid usernames that I have. Now, if there is an account lockout, that's not the end of the world. The account lockout mechanism itself could be vulnerable, for example, if it uses cookies to keep track of the number of failed login attempts. So what you want to do is monitor all the requests and responses until you get locked out to determine if you can potentially exploit the lockout mechanism. And of course, this test applies on all authentication pages, not just the login page. The next vulnerability you want to test for is verbose error message. So the first thing to do over here is submit a valid username and an invalid password and make note of the response of the request. Then submit an invalid username and an invalid password and make note of the response of the request. Compare these two responses together for any differences in status code, any redirects, information displayed on the screen, differences in the HTML page source, or even differences in the time required to process the request. This can be done using tools like Burp Comparer. Now, if there are differences in the response, then you have a way to tell if a username is correct or incorrect. In this case, what's left is just to run an automated attack to enumerate the list of valid usernames in the application. And again, as usual, this applies on all authentication mechanisms, not just the login page. The next thing you should test for is vulnerable transmission of credentials. This one is very simple to test for. All you have to do is perform a successful login while monitoring all the traffic in both directions between the client and the server. And then you just review that traffic to look for instances where credentials are submitted in a URL, query string, or as a cookie, or are transmitted back to the client. Now, if the application uses HTTPS by default, you could also just change that to HTTP in the URL and see if it allows you to perform the login request. Just showing that the credentials are passed in clear text, like in the Wireshark example right over here, is enough proof. You don't actually have to go as far as exploiting the vulnerability and being a man in the middle and intercepting the traffic. Moving on to the next vulnerability, an insecure forgot password functionality. The first thing to do is identify if the application has a forgot password functionality. If it does, then perform a complete walkthrough with an account that you control while intercepting all the requests and responses in your proxy. Then review the functionality to determine if it allows for username enumeration or brute force attacks, or even if it has design flaws like the one we saw in the previous example that could potentially compromise a user account. Now, if the application sends an email address containing a recovery URL, that should definitely also be tested for vulnerabilities. So you would obtain a number of these URLs and attempt to identify any predictable patterns or sensitive information included in the URL. You also check if the URL is long-lived and can be used more than once. If it doesn't expire and if it can be used more than once, those are vulnerabilities that should be reported as findings in your report. Next is defects in the multi-stage login mechanism. This is really similar to the previous one, so the first thing that you need to do is identify if the application has a multi-stage login mechanism. If it does, then perform a complete walkthrough with an account that you control while intercepting all the requests and responses in your proxy. Then review the functionality to determine if it allows for username enumeration or brute force attacks, or even if it has a design flaw, like the one we saw in the previous example that allowed us to compromise any user account that we wanted on the system. Alright, last but not least is checking for insecure storage of credentials. So this one can be tested in multiple ways. The first thing you could do is review all the application's authentication related functionality. If you find any instances where the user's passwords are transmitted to the client, whether in plain text or obfuscated form, this indicates that passwords are being stored insecurely in the backend database. I once tested an application where you could see the logs in the administrator account and passwords were being displayed in the logs. So that told me that passwords are not being hashed in the backend. Another funny story that happened to me once is I forgot my password, and so I ended up calling the service desk to reset my password, and they just offered to give me the password that I forgot, which again immediately told me that my password is definitely not stored in a hashed format in the backend because hashing is a one-way function and there's no way to retrieve the plaintext version of a hash. And so they were storing my password in clear text, and they thought it's okay because this way they could help users retrieve their passwords. But I had to give them a whole lecture about how that's insecure and passwords should be hashed. And if users end up losing their passwords, there should be some kind of reset functionality that is used to reset your password. Another way you could test for this is if you get remote code execution on the server. This way you have access to the underlying server and the backend database. Then you could just review the database to check what format the passwords are stored in. Now, the most common way to test for this type of vulnerability is just to conduct technical interviews with the developers to review how passwords are stored in the backend database. And that's the way that I usually go with when I'm testing applications. You'll have plenty of time to gain hands-on experience in exploiting authentication vulnerabilities because we will go through 14 labs covering different types of authentication flaws in the upcoming videos. Alright, we can't end this section without mentioning web application vulnerability scanners. These are essentially automated tools that crawl your web application and look for vulnerabilities. Now, scanners are good for finding a subset of the authentication vulnerabilities, like credentials being passed in the URL or credentials being transmitted over an unencrypted channel, but they usually miss authentication vulnerabilities that are a result of design or business logic flaw. So you could use a scanner to test for authentication vulnerabilities, but you definitely need to have some component of hands-on testing to make sure that you cover all your bases. A really good comprehensive resource for a step-by-step approach to testing authentication vulnerabilities is the Web Application Security Testing Guide. I always refer to it from time to time to make sure that I don't miss anything when I'm doing a web application pen test, and so I definitely recommend that you check it out. I've got the link to the testing guide up on the screen. All right, we've reached the last section of the presentation, which is how to prevent authentication vulnerabilities. There's a number of ways to prevent authentication vulnerabilities, and just like I can't list all authentication vulnerabilities, I definitely can't list all the ways to prevent authentication vulnerabilities, but what we could do is cover the most common ones. And the first one is, wherever possible, implement multi-factor authentication. Like I said, password breaches happen all the time, and users' passwords are being dumped online on a daily basis. And so it's no longer sufficient that you have single factor authentication on any of the applications that you use. You should definitely have MFA enabled on all the applications. Next thing to do is change all default credentials. You should never ship any software, whether in a non-prod or a prod environment, with default credentials. All the credentials should be changed before the software is deployed. Next is always use an encrypted channel or connection when sending user credentials. We saw in the Wireshark example where if the credentials are being passed over HTTP, then anyone that is sitting on your network can view your credentials and potentially compromise your account. Whereas if it's HTTPS, then it's an encrypted channel and it all appears as gibberish to the attacker since the information is encrypted and the attacker has no ability of decrypting that connection. Next is only post requests should be used to transmit credentials to the server. So you should never use GET requests to transmit credentials to the server because then they're transmitted in the URL, which means that they're vulnerable to shoulder surfing attacks. Also, URLs end up in a ton of logs, which means that your credentials will end up in a ton of logs for people who have access to the logs. And so you should only transmit credentials in post requests. Stored credentials should be hashed and salted using cryptographically secure algorithms. We talked a lot about this one. Credentials should be hashed because hashing is a one-way function, which means that it's computationally impossible to reverse a hash to the plain text password. And it should be salted because that prevents attacks like rainbow table attacks being performed when a breach occurs. Use identical generic error messages on the login form when the user enters incorrect credentials. This prevents the enumeration of valid usernames. Implement an effective password policy that is compliant with NIST 863B's guidelines. So we saw if you have a weak password policy, that means it's easier for an attacker to guess the password, and so you should comply with industry standards when it comes to password complexity requirements. Use a simple password checker to provide real-time feedback on the strength of the password. And we've got an example of a JavaScript library. So this gives the user the ability to check their password in real time to determine the strength of the password, which makes the users more likely to set a strong password. Implement robust brute force protection on all authentication pages. So we definitely don't want an attacker to be able to run a brute force attack to compromise a user's account, which is why you should have brute force protection both at the application layer and then also at the web application firewall layer. Audit any verification or validation logic thoroughly to eliminate flaws. So we saw several examples where design flaws or business logic flaws ended up introducing vulnerabilities that allowed for the compromise of user credentials. And that's why it's absolutely important that any authentication mechanisms should be thoroughly audited and verified to ensure that they don't have any vulnerabilities in them. And that's it for preventing authentication vulnerabilities. There's a really good resource called the Application Security Verification Standard, or in short ASVS, that is built by OWASP that can be used to determine how secure your application is, and it can also be used as a guideline when developing your application. It has a ton of rules that you need to comply with depending on the level of sensitivity of your application. So I definitely recommend that you check it out, specifically Chapter 2, Authentication Verification Requirements, which covers the authentication requirements that your application should comply with. All right, we've reached the end of our presentation. I've added some really useful resources on the slide in case you're interested in learning more about authentication vulnerabilities. So the first one over here is the Web Security Academy and the Web Application Hackers Handbook, which is mostly what this presentation is built on. And then I have a few OWASP resources. So the Web Security Testing Guide, which is used to teach you how to test for web application vulnerabilities, and then the Application Security Verification Standard, which is used to allow you to determine how secure your application is and also gives you secure requirements when you're building your application. In the next few videos, we'll gain some hands-on experience exploiting these types of vulnerabilities.